Hello everyone and welcome you all to the series of for Python programming, and this is the very first lecture for Python programming, and this is about the basics of Python. Going forward, we'll be learning about the advanced version of Python, the functions, the loops, the classes, and everything else. And I'll be telling you basic nuances to advanced nuances that are used in Python, how to use in Python, and many other things. So as of this lecture, I'll be covering the installation of Python through Miniconda 3, how to access a Python, how to run a code in Python using an environment, why environment plays an important role while coding, and the various Python keywords and identifiers that can be used and that cannot be used while coding. That should be in your mind. Alright, so let's get started.
So let me walk you through as to what we'll be covering in the series. Basically, we'll just go through basics of Python, the advanced things of Python, the applications of Python, and not just the applications that we are spoon fed or we are told in our colleges or forced to learn or something, but the actual real applications, how Python is used in companies, how Python can be used in future references for various work that is being done for various projects, for various real-time projects. Basically, I'll be covering those things in this entire series, and also be giving few projects as well. And if you want any mentoring or anything related to Python, I'm open to all of it. So moving on.
Before we learn about the basics of Python, let me just walk you through as to why Python is so important and why Python is being preferred by so many people out there. So, Python, while using, is very easy to learn. First of all, it is very quick to grab, it is very user friendly, the syntax is very easy, and also it allows you to write programs in a very fewer lines of codes than most of the programming languages like C++, C, Java, and many others. So, various things can be done in Python altogether when it comes to making APIs, doing some data analysis, doing some data visualization, making some charts, writing some CSV notes, writing a file, reading a file, everything. Anything can be done by Python, the data mining part, and there are so many libraries that can be accessed via Python, which helps you to do various kind of stuff using Python. That is why it is mostly preferred at this point of time. You about the basic installation for vanilla Python, where there won't be any framework or anything, just basic Python. So you can just download it from this link given over here. It will be included in the description, and just after downloading, just install it. And just in order to check whether the Python is being properly installed, you can just open the command prompt as something like this and just type Python in it. So if it shows something like this, where it will just show the version of it, in my case it is Python 3.7.6, and I've installed it to Miniconda, so it will just be providing Anaconda. So this is the basic IDE of vanilla Python, where there is no storage or anything of that code. You just directly do some mathematical calculations in it. You cannot store it. Basically, every time you open something, again open an Anaconda prompt, it will just go away and you have to start over everything. So that is why mostly Anaconda and Miniconda is preferred. Now, what exactly is Anaconda and Miniconda? Anaconda and Miniconda are distributions. A software distribution is a collection of packages, you know, like pre-built and pre-configured, that can be installed and used in your system. So let me tell you the difference between now Anaconda and Miniconda. Now Anaconda is a full distribution of central software for Python. So it includes Python plus all the packages, all the libraries that will be required. It almost will weigh around 3 GB or something. Whereas if you go for Miniconda, Miniconda doesn't have anything in it. It just comes with a package of Python and a base where you can just install the packages that you really want. So I use Miniconda myself. To sum it up, Miniconda is essentially an installer for an empty Conda environment containing only Conda, its dependencies, and Python. So now the question is, what exactly is Conda? Now Conda is just the package manager that helps you install packages in Python environment, right? So now Miniconda can be installed from this link, which is also provided in your description. And again, the required Python version accordingly, your bit size, you can just download it. And once you download it, install it as well. And once you install it, just make sure while installing that you uncheck the add to path button, or else you'll have to do it manually while going into my computer setting and adding the path where your Miniconda will be present basically. Once you install the Miniconda, do the next steps of it, like install Miniconda with add to path unchecked. Current Miniconda Python version is 3.7.6. Now open the Anaconda prompt, or let's say command prompt in your case, and first of all start with writing pip install JupyterLab. Now pip is the library for Python, as Conda is the library for Miniconda or Anaconda. In the same way, pip is the library for Python. Since we have to install JupyterLab into Python, we'll just add pip install JupyterLab. So while we do it, let me just show it. Oh, it's still in Python. So pip install JupyterLab. So it says requirement already satisfied. Since I already have JupyterLab installed in my computer. Now Jupyter Lab is something very similar to Jupyter Notebook. If you have heard, if you have not heard, okay, let me tell you. So let me just show you before that. Now once it is installed, I'll just show the Jupyter Lab, how it looks and what are the basic functionalities in it. Right. So here I've made a project named as Untitled 4, and I just added a line saying print hello world, as this is what all the basic programmers tell you. So this is the only thing that you have to do in Python. Just print hello world in quotes, and it will just provide you an output. So this is how the look of Jupyter Lab is presently. It basically runs in cells. This entire thing is called a particular cell. Right now, you have your directory, any file, anything that you do, it can be provided, it can be accessed. Now this is the kernel sessions. It tells you how many notebooks of yours are running at a particular point, how many kernels are assigned to a particular book, and what are the books that are running basically. Now these are the various basic tabs, commands. Then this tells the last thing that you ran. Open inspector, open tabs, the tabs that are open. Extensions play a very important role when it comes to plotting or showing charts on Jupyter Lab. We'll just see it in future lectures. So the best part also about Jupyter Lab is it almost gets saved in every 30 minutes or 40 minutes. You don't have to save it manually. Yeah, so this is much of Jupyter Lab. This is what tells that a Python is installed in your computer and it is done and you are all set to do anything you want. Now let's talk about environments. So environment plays a very important role when it comes to working in offices and real-time projects. Let's say I have two projects, A and B. I have I have installed libraries for both the projects. I have, let's say, coincidentally have same library but different versions of it. So when you install a particular library in a particular base environment and the same library you install of different version in the same environment, it might get overlapped. And it might hamper the first project, or it might hamper the second project based on the versions that was required and being changed later on. So for that, it is way too preferred that you always work in a closed environment by making an environment, by making a virtual environment as it is said, so that whenever you deliver a project or give a project to your client, you just tell them that these are the libraries that are being worked for this project, and one can easily copy or one can easily access it and follow your footsteps basically. So let me just walk you through as to how an environment can be made. You can just stop the Jupyter Live by clicking on Control C. Right. So as it is showed now, the next is, once you install pip install Jupyter Lab, next is conda create hash n test. So here hash n test is the name of environment. Let me just show you. So let me write conda create hyphen n test. Test is the name of my virtual environment here, and here 3.6.5 is the version of Python that I'll be requiring for that particular project or for that particular virtual environment. Or let's say I'll just write 3.7. Now this is for all the versions above 3. For all the versions or below 2.7, you just have to write conda create hyphen n, the name Python is equal to 2.7, the version of it. Right. Now if I do like this, it will just ask me remove existing environment. I'll say yes because it is already made, so it is asking me again. So now once my environment is being made, so now I can access the environment by activating it by writing conda activate the name of the environment, which is here test. Now you can see instead of base, test is over there. So firstly, the environment of mine was base, that is the actual environment, the Python 3, which you downloaded with Miniconda 3 in my case, or even vanilla Python or anything. And here I just switched it to test virtual environment. Now I'll just write my pip list just to see what libraries are installed. You can see here these are the basic libraries that comes with the package, and if I want to install any extra library, I'll just install pip install pandas. So it will be getting installed. While it gets installed, I'll just show you how it will look. So now my libraries are installed. Just to check if my pandas is installed in this environment, I'll just say python 3.7.7, which I just installed for this particular environment test. I'll just write import pandas. Yeah, so it worked, right? I'll just go back, and the very next steps is installing. So there are two things now. One, I'm making an environment. Second, I'm using it as a kernel. As a kernel as in to run my basic blocks on Jupyter Lab. So if I want to activate that, if I want to do that, I'll just do the following steps, which is my step 5. So I'll just So I'll just deactivate the environment. Now I'll say activate my test. I'll say pip install kernel. So this is what allows me to add my current environment in a kernel. So once you install it, I'll just add that thing. Right. So this is done. I'll just now write ipython kernel install hyphen hyphen user hyphen hyphen name of the environment that you want to upload. Now hyphen hyphen display name, and in quotes, in double quotes, I'll just write the name that I want to provide it on the kernel. Let's say if I write test kernel and the version of it 3.7, just to understand it better, and just do it. So you can see install kernel spec test, and this is the path that will just tell you that this is where your thing is loaded and done. I'll just deactivate it and run the Jupyter lab, just to make sure don't run Jupyter lab in your environment, since your Jupyter lab is not installed in an environment, it is installed in your base package, base Python, right? Right. So if you see now here, I see the test kernel 3.7 which I provided, and as I click on it, I'll just see over here test kernel 3.7. And if you remember, we installed import pandas library. So I'll just do import pandas as pd. So see, it worked. It worked fantastically. It worked. Yeah. So this is what about the environment creation and stuff. Now there are various things. If you want to remove an environment, just do conda remove hyphen hyphen name test. That is the name of the environment that you want to move, and hyphen hyphen all, right? And also, if you want to remove the kernel from your Jupyter lab, just use the line Jupyter space kernel spec space remove the name of kernel. That is test in my case, right? So I won't be doing that, but yeah, you can do that anyway. Yeah, if I want to see how many kernels are there are two ways. If I can directly see Jupyter kernel spec list, it will just show me the list. So Python is the very basic one in the test which we just made right now, right? So we are good to go. Just activate any environment that you want to work on dedicating to that particular project, and you are good to go for that thing, right? So next thing is the identifiers things, that is Python keywords and Python identifiers. Now Python keywords is something like true, false, none, and all this list that is when provided, which cannot be considered as identifiers. Identifiers is something like giving a particular name of a variable. Say I'm saying a is equal to 1, so I'm assigning 1 to the variable a, but I cannot write false is equal to 1, because these are keywords, not identifiers. This actually means something. Similar way, you cannot use all the given words, all the given keywords, and use them as identifiers in order to store a value, a particular value, right? So this is it. This is the thing. Now, basic rules for identifiers, or let's say I'd say variable names are, you cannot write a name of identifiers as a number. You cannot just assign a value or anything or a string to basic number. You cannot say 1 is equal to in a string 2, or 1 is equal to string of m or I, anything like that. You cannot do that. Wait, I'll just show you once. Oops. Right. So as I said, you cannot just assign a particular value to a name. You know, this cannot be done. You cannot assign to literal, the syntax error basically, or you cannot do something like a special character. You cannot do this as well. You cannot include in the name of variable a special character, or start a name of an identifier with a name with a numeric value, basically something like at the rate value, or let's say one value. You cannot do that, but instead you can just basically write value, or you can add as a suffix and not a prefix. Value 1 is equal to 2. When I print value 1, I'll just see 2 value that was assigned to it. Alright, so this is much for the first lecture. Let me know in comments how it was, and if I need to add something. Thank you everyone.